Hey everybody, welcome to Wednesday, April 8th. It's going to be a really short video, basically just a warm-up and then kind of get you started on your class assignment. So let's jump right into it. Okay, so we are still working on kinematic equations. And still getting this idea of free fall and all this kind of stuff. And today we're going to be doing a concept builder, a simulation activity similar to one you've already done. All right, but as always, here's a warm-up problem. Do this in your notebook. It's a good practice problem, good example problem. Try it on your own, see if you get what I get. But we got this penny being thrown, or dropped, I'm sorry, from the top of a skyscraper. And we want to know two things. We want to know the amount of time that it'll take for the penny to reach the ground. And we also want to know the final velocity. So with any problem, we always draw a picture first. So I got this balcony here, 370 meters off the ground, going down. Second thing we do is we always write up all of our knowns and unknowns. So notice that I put delta x as negative 370. Anytime something's falling, it's going to be negative. This one's nice because it's dropped, so that means the initial velocity of the penny is going to be 0, and your acceleration is going to be negative 9.81 meters per second squared, and we are looking for time and final velocity. So the first thing is it wants time, and we don't know final velocity, so that means we have to go with our 1/2 AT squared equation because it doesn't have final velocity in it. Now, if you're a little scared after yesterday's problem, don't worry about it too much because this one's nice because the initial velocity is 0. So that whole term goes away and we don't have to worry about quadratic functions. So now it's a matter of just plugging in and solving for time. You get 8.7 seconds. So that takes care of part A. Part B says, what would be the final velocity? Now you might look and say, hey, now I have time, I can just use this equation and plug everything in. But in physics, as often as we can, we try not to use answers that we've already solved for. Now you could use this, but like I said, we try not to use answers that we've already solved for. So then the question is, knowing this information and not knowing time, how can we find final velocity? Well, my favorite equation is the one when there is no time. We use the VF squared equation. So that's the VF squared equation there. And we simply plug everything in, substitute everything in, and solve for our final velocity, which is a negative, and that makes sense because it's falling down, 85.3 meters per second. And this, and I just remembered, don't forget when you square root something, you have these two negatives in here and they would cancel out. When you square root it, if you put it in your calculator, you'll just get a value. And you might be tempted just to put 85.3 on there. But remember, from math, whenever you square root something, you actually get a positive and a negative value for that. So you have to determine in physics whether it should be positive or negative. Since we're falling down, then it's negative. So what you're going to do is, the first thing you're going to do is go on to Google Classroom, go in the classwork tab, and there is a link to a concept builder. And what I want you to do is click on that concept builder and work through it. And I would like you to get all 3 gold trophies. This one won't be that hard. It should not take you very long. Once you get the idea of what's going on, it goes pretty quick. I did it in like 4 minutes, but obviously I knew it was going on once you see it. So just as a reminder, velocity and acceleration are vectors. So they both have a magnitude and a direction. So when you're doing this activity, make sure you keep that in mind. Once you finish that, take a screenshot of it and submit it to that Google Classroom assignment, and then start working on the acceleration word problems homework. And that's it. So if you have questions, please email me. Office hours are 11 to noon, and I will be checking my email often. Talk to you later.